Okay, so in this video, I am going to provide a brief overview of the changes that you can expect to see in version 9.0.6 of the Tycho software. So here is the changelog file, and these are the changes. The first of which is the ability to export the photometry data into the heliocentric Julian date format. So as one example here, if you go to the calculators menu, there is the date calculator. And there is now a new column. This is the heliocentric Julian date column. So if you type in the coordinates of the object as well as the heliocentric Julian date, it is now able to convert from that to the regular geocentric Julian date and vice versa. So it can convert from one to the other. And just as an example here, the difference for that particular date and time in that object, if we are curious to see what that is, so 0.80311 minus 0.081446 multiplied by number of seconds in a day, it comes out to about 143 seconds, or a little over 2 minutes. And that's basically that compensation, taking into account again the position of the object and the observer position of the sun and so forth. So the meaning behind this, the actual value in that is that we can now export, again, photometry data using that date format. So if we go to File, if I can load from repository or autosave, either one, I can import an object, and then let's say I wanted to export that data. I could do so into a text file that has a date, magnitude error columns, and that's going to prompt me for a delimiter between those columns as well as the date format. So now we have the regular Julian date is one option, the heliocentric is another, or even a Unix timestamp if we wanted to do that, which is simply the number of seconds elapsed since 1970. So heliocentric is now an option, and we can also do that for AAVSO export. So if we wanted to generate a report for AAVSO, we have that option here, again, regular geocentric Julian date or heliocentric Julian date. So either one is now an option, and that's a nice feature to have. Another feature here, again, new in version 9.06, some have been interested in the ability to work with different bits per pixel for different images. So if you had multiple images and for some reason some of them had 32 bits per pixel and others had 16, Tycho obviously previously worked with both of those formats, but not at the same time. In other words, it would give you an error message if you tried to load images of mixed bits per pixel. But now it will simply give you a warning. So as one example here, if I go to an image that has that's negative 32, so that's the floating point, 32 bits, and then I go to another image file that has got 16 bits per pixel, then it gives you a warning. So in this sense, the warning is simply, it's highlighting that column and these different rows here. So 16 for this image, negative 32 for the other. So it will still allow you to view those images. Of course, the restriction is they have to still have the same dimensions for various reasons, but that is now an option. Another feature here is a nice one. So this observing circumstances table. So if you are publishing your photometry data into the Minor Planet Bulletin, now you have the ability to essentially generate that table. So here's an example. This is asteroid skip 1884, and let me just go ahead and give a brief overview of how that works. So I'm going to attach object data to it, so click OK. So we've got the coordinates of the object, the phase, and so forth. Those are available. I'm going to do a find period search, and it comes back with these results. And again, this is in the light curve window. So from the light curve window, you can now go to File, Observing Circumstances, and now you have this new window, and it has populated this table here. So phase, the phase angle bisector, values, the period, period error, amplitude, and amplitude error. So these are all values that you may want to have available if you are going to publish your results into the Minor Planet Bulletin. So these values will also update if you identify a different period. You'll notice it updates it here. So it's a real-time display there. And if you do not have, if the values here are 0, that would be the case if you had not yet conducted a period search. So you always want to go through the whole process of loading in the photometry data, attaching object data to it so it has the phase info, and then doing a period search. So once you've done all of that, then you can do your observing circumstances here, and it will have all of these values computed. And more details are also available in the user guide. And finally, the last item here is the ability to extract compressed FZ files from within the image manager. So if you are working with images that have been, for some reason, compressed, then you have now the ability to work with those. So it's one example here. I will delete the extracted files. So what we're saying here is we're going to pretend as though we've just been given these 4 compressed images, and now we want to view them. So I'm in the image manager, and I've selected these images, click open, and now it has extracted all 4 of them. And I can go ahead and view them. So here are these 4 images here, and you can see that in the image viewer. So it's animating between the 4 images. So it's basically, that's a seamless operation. You don't have to do anything manually. It's basically going to do it for you. So you can load these compressed images just as though they were normal FITS images. And so the only caveat there is that you want to make sure that the folder that contains those compressed images is writable. In other words, not a read-only directory. So anyway, that's about it for now. Thank you for watching, and see you next time.